Welcome students to this channel. Today I am going to discuss arrays in general and one dimensional array in particular. So just have a look. So what is mean by an array? Firstly, few important points. So array is nothing but a collection of similar data elements. Collection of similar, or other way of saying, homogeneous data elements or values. Next very important point is array always takes contiguous memory allocation. Takes contiguous memory allocation. Next important point related to array is indexing applicable. So always there is an index for each and every cell. Indexing applicable. One more and very important point, that array name indicates its base address. So related to the addressing part, I already discussed in the previous video. Those who haven't watched that video, they can go through that video and the link is available in the comment box of this video. Okay, now let us go through in detail in each and every point. So in general, array is declared like this. For example, integer a of 5. So the compiler will understand, basically this is what? This is a declaration statement or declarative statement, and this square bracket after the variable name is always indicates that this a is nothing but an array and this is the number of elements. So 5 elements are there in array. Okay, so this, what is the impact of this line? This is a declaration, and already I told you that purpose of declaration is memory allocation. So 5 contiguous blocks will be reserved for your variable a, or other way of saying for your array a, like this. So this is 5 contiguous blocks. So this point satisfies that, takes contiguous memory allocation. Okay, and indexing applicable, this is also valid. Why indexing applicable? Because each and every cell has a unique index. So this is index 0, this is 1, this is 2, this is 3, and this is 4. So this is point. Now for example, I want to write, or I want to store some value, say 10, in the 0th cell. So this is the way of writing that a of 0 is equals to 10. So this 10 is stored here. But if you want to write like a equals to 10, it is invalid. This will not work. Okay, this is error. Why? Because a is what? A is not a normal variable. It is what? It is an array. So this point plays an important role, that array name indicates its base address. So this is an address, and you cannot store any value to any address, means this is ultimately pointer. Okay, So what is pointer? Pointer is used to hold the address. So this can only hold address rather than a value. Okay, so for example, this is an integer array. So integer array, let us assume the base address of this array is 1000. So then the next cell address is 1002. So I am assuming here that each integer variable is taking 2 bytes. So that's why 1000, 1001 will be occupied by this cell, 0th index cell, 1002. So what is the next address? 1004, then 1006, and then 1008. So this is the addressing. So this A indicates base address. Okay, so if you print A, so in our case, so this will give you what? This will give you 1000, okay, rather than 10. And if I want to print the value as 10, so I am supposed to print like A of 0. So this will give me 10 as the answer. Okay, so this is very much important point, that array name indicates its base address. Very important point, base address. Okay, and in the previous lecture I told you that variable name indicates what? Its value, whereas array name always indicates its base address. So now let us look this concept in more detail. Now pay attention very carefully. Let us assume I am writing integer a of 5 equals to, so this is declaration as well as initialization. I am also storing the values in that array. So 10, 20, 30, 40 and 50. Let us assume like this. So this statement is what? Declarative as well as initialization. So for this variable a, so 5 contiguous blocks of memory is allocated. Okay. So this is 0th cell, this is first cell, this is second cell, this is third cell, and this is fourth cell. So 0 to 4, overall 5. So some address, maybe the compiler has given the address, starting address, base address as, let us assume 1000. So this address is 1002 in our case because it is an integer array. This is 1004, this is 1006, and this is 1008. So this A indicates this particular array. And also initialization is also done. So the 0th cell value is what? 10. So A of 0 is stored with 10, and similarly it is 20, it is 30, it is 40, and this value is what? 50. Now one more important point. In the previous lecture I told you that internally array uses pointer as the data structure. So now I will show you how this array is using pointer as the data structure. Currently I told you that if you print a, so this will give you what? This is not a normal variable, it is an array. So array name indicates what? Its base address. So what is the a? A is 1000 in our case. Okay, and if you put a star over before that, so what is this operator? This is value at 1000. So this will give you what? This will give you 10, because what is the value at 1000th location? It is 10. Okay, so internally this, how we can print in general in programming language, like a of 0. If you print a of 0, so this will return me as 10. Internally what happened to this? This is internally implemented like this: star of a plus, this is the index value, so it is 0. Okay, now what will be the value? The value is like that: star a is what? A is 1000, and plus 0, this is 0, and it is always multiplied with the data type size. So what is the data type size? So here the data is what? Integer. So integer is integer default. I'm assuming that it takes 2 bytes, so 0 into 2. So what will be the answer in that case? In that case, star of 1000 plus 0, which is nothing but star 1000, means the value at 1000. So what is the value at 1000? The value at 1000 is 10. So this will give me 10. Okay, now let us suppose I want to print a of 3. Now what will be the answer? We know this is the array A and this is the third cell, so this is supposed to give me 40. But internally, how this implemented inside the compiler? By using the pointer. So it is implemented like this: star A plus 3. Okay, now in next step, star, this A is nothing but base address, so base address is 1000 plus 3 is the index multiplied by data type size. So what is the data type size? By default it is 2. So this will return me like star 1006. So what is 1006 address? This one. And what is the value at 1006? So value at 1006 is 40. So this will give me 40. Okay. So one more important aspect, that let us assume if I write 3 of A. Okay, so you can check it by yourself. This and this statement is exactly same. How? Internally, how it is evaluated? Like star 3 plus A. Again, what? Star. So it is 3 multiplied by data type size. So data type size is 2 bytes. And this A is what? A is the base address of array 1000. So indirectly it is star 1006. Okay, so which is nothing but the value at 1006, which is what? 40 in our case. I think this is clear to you people. Now in general, I can say that A of I is equals to I of A. So this, what is this I? This I is a index value. So this is similar to star A plus I, and this is also similar to star I plus A. All these values are same. If you want to check, just open the C or C++ IDE, okay, and implement this one. This will give you the same result. Okay, so in this manner, in a single dimensional array, so why it is single dimensional? Because it is having only one dimension, means a single row array. Okay, and one important point that I already told, that this array is having a similar data type element. So all the elements are of what? Integer type. So we cannot store like one value as integer, one value as float, one value as character. So it is not applicable, because array is always meant for similar data type elements. So I think it is clear to you people. Okay, now let us take one question, previous year gate question, and solve that. So what is that question says? The question says that find the location of, so we are supposed to find the location of A of 1000, A of 1000, like this. Okay, for the following C declaration, for following C declaration. So what is the declaration? Declaration is like this: integer A of like 5000. So we are supposed to find location of this. Okay, so already I told you that how to find the location. So we are not supposed to find what? Value. We are supposed to find what? Location only. So if I want to, so this is our question and this is going to be the solution for that. So location of A of 1000. Okay, what is the impact of this line? So this is declaration. So impact of this line is something like this, that internally this array A takes the contiguous memory and indexing by default 0, 1, 2 and up to what? So it is the size 5000. So last index is 4999, like this. Okay. Okay. And one more thing is given in question, that base address, they are assuming the base address as 0. Base address as 0 means this starting address of this cell is 0. So now what is the next address? It is 2, because it by default integer takes 2 bytes. So it is 4, it is 6, like this. Okay, so we are supposed to find this. Okay, now according to our scene, what is the base address? So base address plus what we are referring? We are referring 1000. So it is 1000 minus what is initial index? Initial index is 0 and multiplied by size. So what is the size? Size is 2. So base address for this is what? 0. It is already given in question. And 1000 minus 0, so it is 1000 only, and multiplied by 2. So this will give me what? 2000 as the answer. Means location for this particular thousandth, A of thousandth, okay, is 2000 in this case. If this is the C declaration and base address is 1000 and we are supposed to find the location for this. Okay, so in general we can say that, let us assume A is an array. Okay, A is an array. Let us assume it is having some elements, maybe any number of elements. Take any arbitrary elements. Okay, but by default indexing always starts from 0, 1, 2, 3, 4. But this indexing, I am saying that it is by default from 0. Why? Because we are taking C language as an example, but in different languages or in general aspect, because we are ultimately dealing with what? Concepts of gate, concepts for gate. So the starting index, maybe it may be from 1 or it may be from anything. So particularly in this case. Okay, and base address, maybe some base address is also there. So base address, let us assume base address is 1000, and let us take some random values like 10, 20, 30, 40, 50. Okay, and this is 60, and I just want to know what is the location, of A of 5. So I know what is the location of A of 5. A of 5 means this location. So what will be this location? 1002, 4, 6, 8 and 10. So it must be 1010. So how it is coming? Firstly, we are taking base address. So what is base address? Base address is 1000 plus. How far we are supposed to go? We are supposed to go the required index. So what is the required index? Required index is 5. This is the required index. And the required index, so how many cells we moved? So 0, 1, 2, 3, 4. Okay, 4 cell we moved, so fifth cell. So how we go there? Like 5 minus initial. So the fifth is this one. Okay, and minus 0 is what? 0 is the lower bound of this array, and multiplied with the size. So by default the size is what? 2. So what will be the answer? So the answer is 1000 plus 5 into 2. 5 minus 0 is 5, into 2 is 10. So ultimately this will give me 1010 as the answer. Okay, so this is the case. Okay, now let us do one more example. then we will generalize this concept. Okay, so what is that question? The question says that consider the following array declaration. So this is the array declaration. So what is the array declaration? Array is declared like A, and from -50 to like +50. Okay, so it may be some array declaration. This is the declaration, maybe in some language. I am not saying that it is compulsorily in C language, maybe in some. So because it is following negative indexing also, so maybe it is in some other language. Okay, so this is a random question. So this is the declaration, and base address is given. So what is base address? So base address for this array, base address for this array is 1000. It is also given in question. And size of each element, size of each element. So what is size of each element? So they are taking 2 bytes, or let us assume 2, and we are supposed to find the location of A of 0. So this we are supposed to find. This we are supposed to find. Okay. Now how to find this one? So internally this is the declaration. So what will be the impact of this line? So the impact of this line, that A for this array A, okay, indexing is always there. So index will start from -50 and -49, and somewhere in between it may come like 0, 1, it is -1. Okay, and similarly up till here, what? Up till +50, because it is written like -50 to +50. So these are the indexes. Okay, so we are supposed to find this location A of 0. Okay, and each element size is given, base address is also given. So what is the base address? Base address is 1000 in our case, and each element is taking 2 bytes. Okay, so now how to find this particular location? So location of A of 0 is going to be, what is base address? So base address is what? 1000 plus, where we are supposed to go? We are supposed to go 0th index, because it is in the question, 0th index. Okay, minus, so what is the lower index of the array? Lower index is -50, so it is -50, and multiplied with size of each element, means these many elements we have crossed, and multiplied with size of each element. So what is the size of each element? It is 2 bytes, so it is 2. So this will gives me 1000 plus, it is minus minus plus 50. 50 into 2 is going to be 100. So the final answer for this question is 1100. So maybe you can manually count this one, but maybe for some other question you cannot solve that, manually. So this is the general aspect how we can solve this particular question. Okay, so this 0th cell, so maybe you can count that how many cells we have just crossed, like 1 2 3 up to -1 means 50. So 50 into 2, because each cell is taking 2 bytes, so 50 into 2 is 100, and starting from 1000, so 1000 plus 100, so this will come like 1100. Okay, this is the manual part. But what about if I ask you that location of A of, let us suppose -49. So I just want to find the location of this particular index. So what is the base address in this case? Base address is 1000 plus, what we are referring? We are referring -49. -49 is somewhere this particular location. Okay, and minus, what is the initial lower bound of this index cell? This is -50, and multiplied with size. So size is 2. So now this will give me 1000 plus this -49 plus 50 multiplied by 2. So this will gives me, it is 1 only, 1 into 2. So ultimately it is 1000. Now you can observe carefully. This is what? This is 1000. Okay. So I think it is now very much clear to you people. So in general, now I am generalizing this concept. I am generalizing this concept. So in general, in general, consider the following array declaration. Consider the following array declaration. So what is the array declaration? Like A, and this LB stands for lower bound and this UB stands for upper bound. This is the in general declaration. And BA here is what? Base address. BA is base address, and C, we are assuming C is the size of each element. C is the size of each element of an array. So now in general, if I want to find the location of ith index in this particular array, so what will be the general formula? So the general formula is, we are supposed to add base address and add something. So what is that something? This referring index is ith index. So I minus, what is the lower index of this? So LB, and multiplied by the size of this. So what is the size of this? C. So this is the general rule in one dimensional array. Okay, in order to find the location of any cell. Okay, so we can say that, so this is the very important formula, or this we are not supposed to learn this formula. Okay, uh, internally we know how this will come, how this came in picture. Okay, so few important point. First important point is, so if the array is starting from, if array is starting from 0, okay, so to get the first value, to get the first value, no need of adding, no need of adding any offset value. So what is the offset value? Offset value is this, whatever we are adding, this particular thing, this is the offset value. Okay, so if the array address is starting with 0, so there is no need, because that much element is there. Okay, so we already saw in previous example. And so, and in other case, if the array is starting from 1 and if the array is starting from 1, so to get the first value, first value, we have to calculate offset. We have to calculate offset. So we are supposed to calculate this one. Okay, calculate offset and have to add with what? With base address. So this is the very general rule, because if the array is starting from like this, if the array is starting from 0, okay, like 1 2, and we are supposed to find 3. So there is no need of subtracting anything or adding any offset, because if I am referring that location of a of 3, so by default base address plus this 3 or multiplied by size, okay, because there is no, because 0 1 2, so ultimately 3 element we skipped, है ना. But in general if it is starting from 1, so we are supposed to calculate this by subtracting the lower bound from that. I hope this is clear to you people, and if you are following or learning with these videos, so please subscribe and like, and share this particular channel. Okay, happy learning to all of you. Meet you in next class.